Same FRQ, now we do part C. They say suppose the function g is given by this. K and m are constants. If g is differentiable, what are the values of k and m? So as we've said all year, I should not pay attention to k and m. I should pay attention to other clues. Well, I remember problems that we practiced where to determine that g is differentiable, I need this note. Hold on a second. I need this note because before g can be differentiable, g must be continuous. Again, without a graph, I don't worry about this description. I use this definition, just like we did earlier, except now we're doing it for g. So just like I did earlier, good notation, I find the limit as x approaches 3 from the left of g. So that's using this now. X is a little less than 3. This will be less than 3 plus 1 is close to 4. Square root of close to 4 will be close to 2. So this limit is 2k. I need to find the limit as x approaches 3 from the right of g. So here it is. So up here when x is a little more than 3, I'll have a little more than 3 times m plus 2. 3m plus 2. In order for, I also have to find g of 3. So that's back here when x is equal to 3. 3 plus 1 is 4. Square root of 4 is 2. That's 2k. These three must be equal for g to be continuous. G must be continuous for g to be differentiable. So I figured out an equation. It doesn't help me find k or m yet, but I can keep going at least. And if I write that equation down, the grader sees it, the grader will give me one of the 3 points. So moving on now, I know that to be differentiable, I had to be continuous first. I figured that out. Now I ignore that because it's not a graph. I need this. I need to work on the derivative of g. So I need to take this formula for g and find the derivative. Well, k is a constant, so it doesn't do anything. This is the square root. The derivative of the square root of something is 1 over 2 times the square root of the something multiplied by the derivative of the something. But the derivative of x plus 1 would simply be 1. So the derivative of this is this. They tell me that g is differentiable. So I can go ahead and put the equal sign right here near x equal 3. Normally I wouldn't put the equal sign until I prove that g is differentiable. But in this case they told me g was differentiable, so the equal sign is okay. I need the derivative of this. M times x, that's a constant times x. The derivative will just be m. Plus the derivative of 2 is 0, so now I have this. So I use the definition now. The limit is x. The nice thing about this problem is that it seems like you're doing the same thing twice. The limit as x approaches 3 from the left of g prime. It means I'm plugging in a value of x that's slightly less than 3. So close to 3 plus 1 is close to 4. Square root would be 2. 2 times 2 is 4. That's 1/4 k. So this limit is k over 4. When x is slightly more than 3, I'm using this. X is slightly more than 3. The value of g prime is exactly m. G prime of 3 goes back up to here. Plug in exactly 3, we get exactly k over 4. For f to be for g to be differentiable, these all 3 must be equal. Therefore I have a new equation, m must equal k over 4. If I get that far, they'll give me the second of the 3 points. Now I have 2 equations with 2 unknowns, the green and the red from the earlier part. I can use these 2 to go find k and m. I will take the k over 4, put it in place of m. And now I use algebra to solve for k. I don't like fractions, so I first multiplied both sides by 4. So 2k becomes 8k. The 4 here has to distribute. So the 4 times this will get rid of this, but the 4 distributes to give me an 8 here. If you can't quite see that, I'll write it out. Sorry, that should be a 4. So the 4 distributes, you get 8k. The 4 distributing here, the 4's divide out because these are all factors. Plus 8. Solving for k, subtract 3k from both sides. This side becomes 5k. K is equal to 8 over 5. I can now take this value of k, plug it back into here. So here's my formula. I'm putting 8 over 5 in place of k. Dividing by a fraction is the same as multiplying by the fraction's reciprocal. So this is 4 over 1, so I'm going to multiply by 1/4. So that gives me 8 over 20. You really don't have to reduce. You could simply leave that as an answer. If you had that answer, 8 over 20 equals m, you've got to have the equal sign. That would get you, along with these, so these two blue boxes together get you the third of those 3 points.